image is formed at eye, but when the object will move towards the mirror, so towards the mirror आपके पास है in the direction as shown in figure, right? Mirror in the direction shown by the arrow. So let's say आपके पास suppose the new position of the object is here, right? Let's say this new position of the object is here. तो आप मुझे ये बताइए कि what was the rule? The rule of thumb was कि whatever the position you select, this is new position, then just draw a cross line, ऐसे ही ना? तो सीधा सीधा आपको दिख रहा है if I'm going to D, angle is not 90. If I go to C, angle at the mirror is 90. If I go to B, angle is again not 90. If I go to A, angle is not 90. So the simple, आपको एक शॉट से ये क्वेश्चन सॉल्व हो जाना था, ठीक है, बाकी जरूरत ही नहीं है इसके ऊपर जाने की. So the line should be perpendicular to the mirror, and the if this is at C, the distance of this object from the mirror should be equal to the distance of image from the mirror. So this is the new position of the image. Is this very clear to everyone? Any confusion in
Yes,
that?
sir. Also, sir, the image is virtual only on the back of the mirror, right?
Perfectly, because for your mirrors, the image is always virtual and behind the mirror. Okay?
So
Okay,
you just have
sir.
to drag a straight line through all of them to make sure
Yes.
that you get the right answer.
Yes.
Got it.
Also, sir,
Is it clear to
for
you?
question number 14 on slide number 41,
Okay.
what is the answer? Because you did not mention the answer.
The image of a point on the lamp formed by the mirror is, mirror can never make real, so cross it, cross it. So uh, virtual will be at point P and it's virtual, at point R and it's virtual. Diagram is not there. Yeah, diagram is there now. So lamp is here. So oh my god, again just draw a straight line, because the mirror image will be exactly, yani the image will be exactly in front of the mirror. Okay, so here will be the lamp. Totally clear.
Okay, so we'll be at P, right?
R is the position of observer. Is it clear?
Okay, yeah, I got it.
This is the position of observer. Yes. Done?
Yes,
Any more
that's it.
question?
No, that's it.
Okay, Ariba, you completed this task.
A bit of it, sir, yeah.
Okay, so now we are talking about the refraction. Refraction of the light is basically the bending of light when it turns from one medium to another medium. Here, refraction is what? The process in which light changes its direction when it passes from one medium to another medium. Yani, the light speed decreases or changes, and then its direction changes. So angle of incidence would be definitely, yani angle will be changed. So this all will be discussed in this part of the topic. So here the important things are that where is the angle of incidence, where is the angle of refraction, when the refraction will be caused due to bending of light towards the medium, towards the normal, when it will be caused due to bending of light away from the normal, etc., etc., and what will be the what will be the criteria for the bending, yani refractive index. So these all are the points what I have to discuss with you in this topic. So first of all, this is an example of the refraction of light as it passes from air to glass. So air is basically less denser medium and glass is more denser medium. So when it moves from less denser to more denser, what happens? Its speed changes. This is your less denser, and this one is your more denser. So in more denser, definitely the transverse waves get slowed down. So when it gets slowed down, it it its wavelength changes and it bends towards, and now this is more denser, and here it is less denser. So when it is less denser, it is simple. When it enters from more denser to less denser, its speed increases and it bends away from the normal. Here it was bending towards the normal. So I will make all these points step by step here. Yeah, third point, when the light enters exactly 90-degree on the surface, yani angle of incidence is going to be zero, then angle of refraction is also going to zero. So no bending takes place. So these 3 points should be under consideration. Okay. So uh just let me write some points for you, summary points, then we will move forward. I'm just writing some points. One is that more, sorry, less denser to more denser, right? First point is less denser to more denser, less denser to more denser. So what did you observed for less denser to more denser? What are the points?
The
Yes.
speed decreases.
Oh, very good. The light gets slows down. Sorry, yeah. Speed and wavelength decreases.
Frequency remains same.
Yes, exactly. Frequency unchanged.
The angle of
And
wait.
third, bends towards. Yes, bends towards normal, and angle of incidence will be greater than angle of refraction. And most probably, because later on I have to add this rule, but that is why I'm going to add it right now. That angle of, yani, the refractive index will be equals to sine of theta I divided by sine of theta r. This would be your game for when the light enters from less denser to more denser. Is this clear to all? These are
Sir,
Yes,
could you
sir.
four
elaborate on
important.
that?
Yes. Sorry.
Could you
Repeat.
please elaborate on the equation one?
Yes, yes, yes. I will go to that. Just this is a bit of, yeah, this is a wallet for your reflection. You have to keep all these points in your mind, recall them, right? I will explain them all, but you have to recall them first because they will be used as it is. Okay. So, secondly, more denser to less denser. More denser means glass to air. More denser to less denser. Are you getting my point?
Yes, sir.
This first mechanism is, you can say, air to glass. When the light will enter from air to glass, this all will happen. Ariba, when the light will enter from air to glass, its speed increases, its wavelength increases, frequency remains unchanged, it bends towards the normal, angle of incidence would appear greater than angle of refraction, and the formula what will you use? It will be refractive index is equal to sine I divided by sine R. Got it?
There's no change in the formula, right?
Where?
Like, the all the properties they get reversed for like denser to less denser, but the
Everything.
formula
Formula will
stays
also be
same,
reversed.
right?
No, 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 no. Formula be reverse हो जाएगा.
Oh,
Sine.
okay.
Speed
So sine R by sine A.
and wavelength increases. Is it clear? Ariba, you were asking something to me. So is this clear to you now?
Could you go over it one more time?
Yes, here. Frequency, when the light enters from more denser to less denser, mean glass to air. Glass to air. When the light is entering from glass to air, then you have to keep these 3 4 points in your mind. The speed of the light will increase, wavelength will increase, frequency will remain unchanged, and bends away from normal. Bends away from normal.
Could
When
you
it
give an example
bends,
on how?
no
Like
need.
what it
I
looks like?
told you that it is just recall. Then in next slide, I will explain each and everything. Okay.
Okay.
First, you have to recall all these points. कुछ चीजें कुन फायकून वाली होती हैं, समझ आ रही है तुम्हें? बस जो कह दिया वो
Yeah.
करना है। इसमें कोई समझने वाली चीज नहीं है, तुमने ये सारा याद करना है। दिस विल हेल्प यू आउट इन एग्जाम। आगे वाली स्लाइड्स में मैं एक्सप्लेन करता हूँ। सो व्हाट यू हैव टू रिकॉल कि व्हेन लाइट एंटर्स फ्रॉम मोर डेंसर टू लेस डेंसर, मीन ग्लास से जब लाइट एयर में जाएगा तो its speed and wavelength both will increase, frequency will remain unchanged, it bends away from the normal. That is why fourth property is that angle of refraction will become greater than angle of incidence. And the most important character of the light, yani which would help you out in calculation, that is the formula for the refractive index would be sine theta r divided by sine theta I. Sine r divided by sine I. Yani everything is reversed, everything. Just frequency remains unchanged. Did you see? Yani, can you compare this all?
So they're just opposite to one another, right?
Yes, because they're definitely their medium is opposite. That's why their characters will be opposite. अब आप देखो, we have a ray box. No need to just go in detail of that. This is the diagram. Yes, the results are here. Did you notice that when the light is entering from air, this is your air, yani less denser, this is your glass, and this is again your air. So when the light is entering from air to glass, did you notice that it is bending towards the normal?
Yeah, it is. It is.
Go back to this. Just go back to that. अब मुझे ये बताइए, this is the real time image or photograph. So if I just draw the line, if the light was entered here, what was the original path of the light ray? Was it supposed to go in this direction?
If it
Yes.
है ना?
wasn't refracted, then
If
yes.
has no bending, nothing, no refraction, so it will go in this direction, है ना?
Yeah.
This is your unbent light, yeah, unrefracted refracted light ray. Am I right?
Yes.
Okay. अब मुझे एक और बात बताइए. If I draw a normal on this glass slab here, so can I say this is the normal? Yani, yes, this is the normal because this is 3D. So you have to just see this edge. ये वाला edge देखो. If this is the edge, so is this green line a normal here?
Almost. But is it perpendicular to the
Yeah,
surface?
perpendicular ही
Actually,
होता है ना. Normal is
it is.
perpendicular. It is ना?
Hmm. Yeah.
Okay. So इसका मतलब ये हुआ कि now the light is following this path. So is it bending towards the normal or not? देखो, the light was supposed to move in this direction, but now it is drifting towards the normal. ये देखो ना, light normal की तरफ आ रही है ना. So isn't it towards the
Okay.
normal?
Yeah. Yeah. Yes. It is.
Ariba, Maryam, Zainab, Khadija, and Iza.
Ji.
Is this
Yes,
clear to
sir.
all of you?
Yes.
Yes, sir.
Okay, so that happens because the light is slowed down, and when the light slows down, it bends towards the normal. When the light slows down, it bends towards the normal. And did you notice that angle of incidence is greater than angle of refraction?
Yep.
Angle of
Yep.
incidence कहाँ पे
Yes.
है? आप देखो, angle of incidence is this. So this is your I, and this is what? This is your R. So is it visible to you that here I is greater than R, bending is
Yes, sir.
towards the normal? So these all are the evidences that light is slowing down when it enters from less denser to more denser medium.
Got it, sir.
Got it? सबको
Yes.
क्लियर हो गया? अरे भाई, your problem is solved
Yes,
now?
sir. Yeah.
Okay. Second thing, just draw normal here at this point. Normal is this one. Here is a line, yani surface, and normal green line is perpendicular to that. So this is a normal. Green is again a normal. And just tell me one thing: if the light was not supposed to bend from when it is leaving the glass, so it should move directly straight, is it? I'm just going to draw a line which will show the path of light without bending. Oh, sorry. It was like this. Anna? Is it like this? Should it be like this? Without bending?
Yeah.
Am I right? So
Yeah.
this is the light which is unrefracted again. But did you notice one thing? That what is the behavior of the light when it is leaving the light glass slab? What is the angle? Yani, this is a real time observation. So here is basically the bending of light. So is this very clear that the light is coming away from the normal, right? By this angle, isn't it moving away from the normal?
Yes, sir.
Yes, sir.
So because the light is entering from more denser to less denser, that is why it is bending away from the normal. And now if here is I and here is R, so isn't it again clear that your in this case your theta R is appearing greater than theta I, is it?
Ji.
So this is what I have explained you in your previous slide. So that is why the formula what I have given to you, you will use that formula when here n is equals to sine I divided by sine R when the light is entering from air to glass. And then back to this, when your light is entering from glass to air, what would be the alteration? Your refractive index will be sine of theta R divided by sine of theta I. Is it? Is it
So
clear
what
to
does
you?
N stand
Everyone?
for again, sir?
Yes. Here, N is the refractive index. What is N? N is refractive index. And I will talk about that in detail. It is basically the ratio of sine of theta I to sine of theta R. R, you can use another definition. R, the refractive index is the ratio of, both are used, ratio of speed of light in air, speed of light in air to the speed of light in medium. Okay, so you can say that from this definition, n is equal to c by v. This is another formula which will be used. Yes, yani ratio of speed of light in air is c. Speed of light in air is c, and speed of light in medium is v, which is less. So you have another formula which is n is equal to c by v. It is n is equal to c by v. Clear? Hai?
Ji.
Yes, sir.
Yes, sir.
So you have to use this formula for the calculation. जी sir. No, no, no. अपना टाइम यूज कर लिया बेटा. एक तो बच्चे इतने शरारती हो गए ना. The allocated time they use on TV, and rest of the time they use on computer for gaming. Okay, चलो हम भी करते हैं कोई सिस्टम इनका. Okay, यहाँ तक क्लियर है सबको? कोई कंफ्यूजन, कोई क्वेश्चन? You want to ask me something?
No, sir, nothing. Got it.
ये तो अभी मैंने यहाँ पे एक एक चीज रिफ्रैक्टिव इंडेक्स, इट्स ईच एंड एवरीथिंग आई हैव बेसिकली डिस्क्राइब्ड ईच एंड एवरीथिंग इन डिटेल. तो आप गौर से देखो कि रिफ्रैक्टिव इंडेक्स इज व्हाट, रेशियो ऑफ sin I to sin R, that is known as refractive index for the medium with respect to the vacuum, I by R. और फिर आप लोगों के पास है, if the value of refractive index will be greater, there will be more bending in the light. That is why the diamond refractive index of all the mediums is different. For example, if you see the refractive index of air is 1, N for water is 1.3, N for glass is 1.5, and N for diamond is 2.4, 2.43, I think so. So that is why when the light falls on the diamond, it bends in such a way that it is dispersed into colors, and that is called dispersion of the light. ये prism भी इसी तरह करता है. Prism has more refractive index in the bottom and smaller refractive index at the top. That is why it bends the light at different angles. तो इसलिए हम लोग उसको क्या करते हैं कि it splits the light into colors. Is this clear to you? Clear to everyone?
Ji, sir.
Okay. Yeah. Okay. Wow. Everything is there. What I told you, everything is written on the slide, so you can go. This is not to recall that. Then this is the formula for the refractive index. That refractive index is basically the speed of light, uh, speed of light. Yeah, refractive index in terms of speed. So speed of light in vacuum divided by speed of light in the medium. So that medium would have more refractive index, which would make the light more slow. That means that if diamond is having more refractive index, it means that it will have, yani it will slow down the light more, yani light will move more slowly in the diamond to connect it. Okay, so then third relation for your water or underwater objects, the refractive index is the ratio of real depth to the apparent depth. You have to recall this formula. I am just going to tell you if there will be a diagram. No, the bending of light takes place in this way. For example, I will draw a part of the swimming pool, and let's say there is a coin here and the bottom here, and you are just going to see that from the top, from here. Okay, then the light which is coming out of this, the one light will move straight, as I told you, that the light which is entering or which goes perpendicular to the surface, or which has 0 degree angle with angle of incidence, that light will not refract, it will not bend. So this light ray will go without bending. Okay, this is first light ray which is coming out of the water from this coin. Second light ray, that will be entering, or that will be moving towards the eyes. तो अब देखो problem क्या है? The problem is that when the light is leaving this more denser medium, अब आप देखो, that all application I'm going to follow that, apply here. The light is entering from more denser to less denser medium. So is it bending away from the normal or towards the normal?
Away.
Away from the normal, yes. So it is reaching to the observer eyes. Now the problem is actually for the light, for the observer does not have any the observer does not have any concern ke whether light is bending or not. Observer are the light will, yani we will have the image of this coin here exactly. So this is what, from this point to this point, this is its real depth. What is that? This is its real depth. But the depth from this point to this point, this is its apparent depth. Are you getting my point? This is its appearing depth, apparent depth. So if the object is coming closer to the top, it means it is appearing more shallow. Yani you are going to see it closer to the surface. So this is actually again a saying that if real depth would be the same, it would not change. But if a medium has smaller apparent depth, then its refracting index is more. Are those mediums in which refractive index is more, the objects would appear more shallower. Simple. Is it clear to all?
So more the diffractive index, the shallower the object.
Yeah, shallower will be, the object will be seen shallower. It would not be exactly shallower, but the actual object is here. But you
Like
will
it
be able to
looks
see it
shallower.
at more higher. Yes, it looks shallower.
Okay, got it.
Okay? So this is basically here are some problems. I would try to, I have 5 more minutes for this class. So um, I just let me check that whether I would be able to yeah, I would be able to complete the concept of total internal reflection. So these are the problems you people are advised to solve these all as your homework. So this is your homework, so please try this all along with the remaining questions. And if you have any problem, you people will ask me. Now we will talk about the critical angle. Actually, refraction is the next part of refraction. Before this all, we discussed that the light is entering from more denser, sorry, less denser to more denser. But here I will talk about that light enters from where? Enters from more denser to less denser. More denser to less denser. So when it would enter from more denser to less denser, what do you expect from the light? Will it bend towards the normal or away from the normal? This is the actual path of the light. But because the light is entering from more denser to less denser, so this would bend away from the normal, right? It
Yep.
will bend away from the normal. So when it is bending away, there will be a time will come when it would be completely parallel to the surface. When it will be completely parallel to the surface. Are you people getting my point?
So, but for that, shouldn't the incident rate, like the angle of incidence, increase or something?
Yes, yes, yes. It would. It would. I will draw it.
Because the more the
Is
increase
this
in
point
the
clear to
angle
all?
of incidence will lead to more distortion in the angle of refraction or
Yes.
something.
Here, yes, yes. Actually, I would refer to this diagram before moving to that. But here, the game is total internal reflection. This is the critical angle situation. I want to explain this first, and then I will go to the critical. I will go to the total internal reflection. Critical angle is that angle at which refracted light ray becomes parallel to the surface, or the angle of refraction becomes 90 degree. This is basically a concept of critical angle. Critical means you cannot decide that light is coming or light is moving out of the surface or it is trying to get into. So that angle of incidence for which the angle of refraction is 90 degree, that angle of incidence is called critical angle in the denser medium. So here the critical angle, you have to recall it, please recall it. This is a recall question. I will explain it for further calculations, but recall the critical angle is defined as the angle of incidence in the denser medium just forget about this optically denser medium for which the angle of refraction is less denser in 90 degree. Yani, for which the angle of refraction in less denser medium is 90 degree. Simple. If you add more denser and less denser, answer will be more perfect. But if not, does not matter, right? So you have to recall it. यानी ये वो वाला एंगल है, इंसिडेंट एंगल वो वाला इंसिडेंट एंगल है जिसके ऊपर आपकी लाइट रिफ्रैक्शन में एंगल ऑफ रिफ्रैक्शन कितना बना है, 90 डिग्री. ये सबको क्लियर है?
Sir, what causes the angle of refraction to be 90 degree?
Nothing.
No, like,
You will call angle of incidence as critical angle.
so it's like you gradually increase the value of angle of incidence, and once the angle of refraction goes to 90 degrees, that value of angle of incidence will be the critical angle, right?
Yes, exactly this way. Right. Here I was about to explain this before. अब देखो होता ही है कि this is what, just forget about this ray. It is just, it will make you bit confused. यहाँ ये वाली कर सकते हैं हम लोग. ओके, इसने क्रिटिकल एंगल इधर दिया हुआ है. हियर इज द एंगल ऑफ क्रिटिकल, सॉरी द क्रिटिकल एंगल इज गिवन टू यू. आई जस्ट ड्रू इट विदाउट seeing the diagram. अब देखो, here is the critical angle. So if you just forget about these reflected rays before, ये जो आपके reflected rays है ना, these one, just ignore them. Sorry, it is just a blob. You have to just ignore them. When you are going to ignore them, देखो हो क्या रहा है. When your angle of incidence is I1, your angle of refraction is R1. Now your angle of incidence is I2, your angle of refraction is R2. Now your angle of incidence is I3, your angle of refraction is R3. Got it? अब मुझे ये बताइए, are you going to increase the angle of incidence gradually? यहाँ पे आपका let's say it is 10 degree, let's say 20 degree. So let's say it is 30 degree. Suppose let's say it is 30 degree. So are you not continuously increasing the angle of incidence?
Yep.
And what about this? This angle of refraction is suppose 15 degree. Suppose it is 20 degree. So it becomes 90 degree, isn't it?
Got it. So does the
So
angle of
as the angle of incidence increases, what about the angle of refraction? It also increases, is it?
yes.
And a time comes when by increasing, after a lot of increase, the angle of refraction becomes 90 degree.
Yeah, I get it.
Everyone get it or not?
Sir, I have a question.
एक मिनट पहले मेरे क्वेश्चन का आंसर करो. Is this clear to everyone?
Sir, can you do it one more time?
No, I don't have time. Just concentrate for the first time. Okay? दोबारा बता रहा हूँ, पहली दफा से कंसंट्रेशन स्टार्ट कर लो. हाँ जी, अरीबा क्या नाम है, मरियम तुम्हारा क्या क्वेश्चन था?
I'm saying that to the angle of incidence and the angle of refraction, they don't increase with the same ratio, right?
No. It depends. I mean, there is formula, refractive index का formula, उससे हम लोग calculate करते हैं. I will let you know. Okay, I was saying, मुझे कोई और डायग्राम देखने दो अरीबा के लिए. कोई अच्छी सी डायग्राम ढूंढते हैं. Just a second. Yes. इधर देखो अरीबा, इधर समझाता हूँ तुम्हें. अब देखो, this is purely refraction, है ना? This is purely refraction. Angle of incidence देखो, what is this angle of incidence? This angle of incidence is, let's say, 20 degree. Okay, if I give you, 20 degree, 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 20 de refractive index of this medium, you people can calculate angle of critical angle. Okay, just don't take more time. मेरी आगे क्लास चल रही है. आपकी लाइट कहाँ से एंटर हो रही है, कहाँ जा रही है? यस इजा,
जी सर.
the light is entering from denser to more denser to less denser or less denser to more denser?
More denser to less denser.
So which formula will be used for refractive index? हरी अब कैलकुलेटर चाहिए मुझे 3.
Sin I by sin R.
No, sin R by sin I.
हमसे नहीं तंग
Yes,
करो.
Zainab,
जी सर.
sin R by sin I. मरियम सॉरी अरीबा, तुमने इन सबको ना सुपरवाइज करना है ताकि जो कंफ्यूजन है वो हमारी क्लियर हो जाए. मैं साथ साथ सारे काम करवा रहा हूँ.
Worst
This is
at
sin R by
refraction out of everyone.
sorry.
मुझे तो reflection और refraction
रुको.
से कुछ पता ही नहीं है. I'm really bad at it. It's my weakest suit.
बेटा तो वीकनेस बंदे की तभी कंट्रोल होती है ना जब वो ऑब्जर्वेशन बढ़ाता है. तुम सिर्फ देखती जाओ क्या हो रहा है. आर यू डू यू हैव अ बिलीव कि व्हेन द लाइट एंटर्स फ्रॉम मोर डेंसर टू लेस डेंसर, तो यू विल यूज दिस फार्मूला फॉर द रिफ्रैक्टिव इंडेक्स?
Yeah.
Yes.
Okay. Okay, good. So I have given you the angle of incidence 20 degree. Refractive index मैंने आप लोगों को दे दिया, that is 1.5. So everyone is supposed to calculate angle of refraction. जल्दी से.
1.5
1.5 is equals to sin R divided by sin 20. Yes, cross multiply कर लीजिए. 1.5 into sin 20, that
Sir,
is equals to
Zero
sin
down.
R. सॉरी दोबारा बोलिए.
जोड़ ये 0.51 बन रहा है.
I
आगे
Okay,
got
sin R
3.08.
will be 0.51. लेकिन R will be equals to sin inverse of 0.51. सही है?
I got
Shift sign
3.086.
कितना बन रहा है?
3.086.
Never.
यार मेरा 30.86 बन रहा है.
30.86 31 डिग्री हो सकता है because
Oh
angle
yeah,
of
yeah, yeah.
refraction
वो
should
आगे
be
exponential 10
greater
भी
than
था.
incidence. पुत्र ये गलती का टाइम नहीं है. मेरी आगे क्लास
Got
चल
it
रही है, मेरा
done.
सॉफ्टवेयर तेज जा रहा है, इसलिए आप लोगों का सबका सॉफ्टवेयर उसके मुताबिक चलना चाहिए. अरीबा, इज दिस कैलकुलेशन क्लियर टू यू?
Yes.
श्योर. तो इसका मतलब प्रूव हो गया कि इफ द लाइट इज एंटरिंग फ्रॉम मोर डेंसर टू लेस डेंसर, द एंगल ऑफ रिफ्रैक्शन विल बी ग्रेटर देन योर एंगल ऑफ इंसिडेंस, जो कि कितना
Got
था? 20 डिग्री था. अब
Yeah.
आप आगे आइए. व्हेन यू विल इंक्रीज द एंगल, इसी तरह एंगल इंक्रीज करती जाओ, देन द टाइम विल कम कि एंगल ऑफ रिफ्रैक्शन विल बिकम 90 डिग्री. जस्ट डू सी दिस डायग्राम. अब आप लोगों ने मुझे सपोर्ट ये करना है with your calculations. Hurry up. Okay, here I'm going to give you that your R is equals to 90 degree. You have to calculate I. Reverse order है. N is same. Sin R divided by sin I, because light is still entering from more denser to less denser. So what you have to calculate? You have to calculate incidence angle. So sin I is equals to sin R divided by N. तो आप मुझे बताइए साइन 90 करना पड़ेगा ना, बिकॉज आर इज 90 डिग्री एंड
1.8.
एन इज 1.5. यस, दोबारा बताइए बच्चे.
41.8 है आंसर.
यस, सो इंसिडेंस एंगल इज साइन इनवर्स ऑफ, ये जो भी आपका आंसर आ रहा है. पहले मुझे ये बता दो कि स्टेप बाय स्टेप थोड़ा सा क्लियर हो जाए बच्चों को. साइन 90 डिवाइडेड बाय 1.5 का आंसर बताओ जल्दी से.
Sin 90 divided by 0.667.
0.67 कर लेते हैं. तो जब आप इसका साइन इनवर्स लोगे, योर एंगल ऑफ इंसिडेंस विल बी 41 पॉइंट कितना 8. इज इट?
Yes sir.
वेरी गुड. मैं इसको अप्रोक्सीमेटली 42 कर लेता हूं, बट ये है होता 41 नहीं है. अब इसका मतलब ये हुआ कि जब भी आप लाइट 41 डिग्री 41.8 डिग्री पे इंसिडेंट करेंगे इस ग्लास स्लैब के ऊपर, जिसका रिफ्रैक्टिव इंडेक्स कितना है? 1.5 है. सो अगर आपका एंगल ऑफ इंसिडेंस 41.8 8 है तो लाइट क्या हो जाएगी, 90 डिग्री पे रिफ्रैक्ट
It
हो
will.
जाएगी.
Uh,
Is
got
this
it.
statement clear?
Yes, sir.
Everyone clear?
Yes. I mean, yeah.
हाँ भाई, इज़ा बच्चे क्लियर है?
जी सर क्लियर है।
इज़ा, मरियम, जैनब, खदीजा एंड अरीबा, किसी को कोई
Clear,
इश्यू बता
sir.
सकते हो? क्योंकि
No
अगला
issue.
स्टॉप मेरा डायरेक्ट टोटल इंटरनल रिफ्लेक्शन पे. अब आप देखो, टोटल इंटरनल रिफ्लेक्शन का मतलब ये होता है कि व्हेन योर एंगल ऑफ इंसिडेंस बिकम्स ग्रेटर देन क्रिटिकल एंगल, तो instead of 90 degree r would become greater than 90 degree. Very simple concept, यानी डिस्क्रिप्शन. तो अगर आपका ये एंगल ग्रेटर देन 90 डिग्री होगा तो लाइट वापस इसमें आ जाएगी ना.
Yes.
ओके, मैं एक वैल्यू दे देता हूं. लेट्स से व्हेन योर साइन r डिवाइडेड बाय साइन i इज इक्वल्स टू 1.5 यानी रिफ्रैक्टिव इंडेक्स. तो लेट्स से अगर आपके पास साइन r की वैल्यू आप कैलकुलेट करना चाह रहे हो एंड यू आर गेटिंग साइन i एज 45 डिग्री. ठीक है, कितने डिग्री पे आपने ये वाला एंगल अब मैं कितना रख रहा हूँ, 45 डिग्री. कितना रख रहा हूँ?
45.
45. ओके, तो आप मुझे ये बताइए, साइन r इज इक्वल टू 1.5 इंटू साइन ऑफ 45 एंड r विल बी इक्वल टू, इसकी कैलकुलेशन जल्दी से मुझे बताइए, 1.5 इंटू साइन 45. हरी.
It's 1.06.
1.06.
जी सर.
ओके, 1.06. तो इसका मतलब r जब आप लोगे तो साइन इनवर्स आपका कितना हो जाएगा, 1.06. ये आपको मैथ एरर देगा, चेक करो.
जी सर.
यस,
Math error
वाई?
है.
यस, क्योंकि आपके पास 90 से, यानी साइन की वैल्यू, साइन इनवर्स की वैल्यू 1 से ज्यादा नहीं हो सकती. इसलिए हमने ये देखना है कि इफ इट इज 90 प्लस 1 तो आपका एंगल ऑफ रिफ्रैक्शन तो होगा नहीं. तो इसका मतलब फिर मेरी लाइट के साथ क्या होगा, तो लाइट इज रिफ्लेक्टेड बैक इनटू द मीडियम. तो उस टाइम पे आपके पास जो एंगल ऑफ रिफ्लेक्शन होगा दैट वुड बी सेम एज एंगल ऑफ इंसिडेंस. तो लाइट आपकी 45 डिग्री पे क्या हो जाएगी, रिफ्लेक्ट बैक हो जाएगी. ठीक है, इज दिस क्लियर टू ऑल?
Oh, yes, sir.
So this is called your total internal reflection. Okay. Any confusion?
Nope. So after 42, if you increase the
हाँ,
angle of
42 से
incidence, it
बड़े
will be
एंगल पे आप
equal
अगर
to.
फेंकोगे लाइट अगर आप 42 से बड़े एंगल पे फेंकोगे तो व्हाट विल हैपन, द लाइट विल नॉट गो टू basically air, it would come back to the denser medium. So that is basically total internal reflection. ठीक हो गया? Is this clear to all?
Got it.
Okay, so I'm just gonna stop it over here. इससे आगे इंशाल्लाह कल डिस्कशन करेंगे. अब आप लोगों का ये टोटल टॉपिक कंप्लीट हो गया. सो आई नीड ईच एंड एवरी प्रॉब्लम टू बी सॉल्व फ्रॉम दिस स्लाइड. ठीक है ना? एप्लीकेशन एरिया आप लोगों ने देखना है. दैट ऑल इज बेसिकली जस्ट मेमोरी रिकॉल. वालेकुम सलाम. जस्ट मुझे 1 मिनट दे दो, मैं बस ये ब्रेक लगा रहा हूँ, बट अभी गाड़ी रुकी नहीं है. ओके, सो कहाँ पे था मैं? यस, आप लोगों ने ये सारा खुद से पढ़ना है. एडवांटेजेस एंड डिसएडवांटेजेस ऑफ ऑप्टिकल फाइबर एप्लीकेशन एरिया. इफ यू पीपल विल हैव एनी क्वेश्चन, यू पीपल विल आस्क मी. अगर नहीं होगा तो पुत्र ये सारे क्वेश्चन करके लाओगे. ठीक है? ऑल दिस
Okay.
जितने क्वेश्चन
So,
इसके
so
इस
we're done.
पूरे टॉपिक के डोमेन में आएंगे ना, लेंसेज से पहले
So like all the
एवरीथिंग शुड बी डन.
questions in this PPT have to be done.
यस,
Before lens, right?
लेंसेज से पहले फ्रॉम फर्स्ट 100 स्लाइड्स ऑलमोस्ट, या इससे भी ऊपर जा रही हैं, यू पीपल आर सपोज टू वर्क. ये आपके पास 100 कितनी है? यस, 112 स्लाइड्स तक जितने क्वेश्चन भी स्लाइड्स में हैं, एवरीथिंग शुड बी डन.
Done.
सी यू देन
Okay,
इंशाल्लाह.
done, sir.
अल्लाह हाफिज. अल्लाह हाफिज.
Officer.
Nafis.